Hello, welcome to the course of Computer Network. So today we are going to discuss about the modulation. So in this chapter we are going to discuss about what is modulation, next the need of modulation, then the type of modulation, that is analog modulation and digital modulation, and in last we will discuss about quadrature amplitude modulation. So starting with the very first, let's discuss about what is modulation. So here the modulation is the process of varying one or more property of periodic waveform with a modulating signal. That is, we know that a message signal cannot travel a long distance because of its low signal strength. So to make the message signal to travel a longer distance, we need a carrier signal of high frequency. So for that, here in other terms, the modulation is the process of mixing a low energy message signal with a high energy carrier signal so that it produces a new high energy signal which can carry information to a longer distance. So here in modulation process, the three signals are used: message signal, carrier signal and modulated signal. So here the message signal is also known as modulating signal or the baseband signal. So here this signal which contain a message to be transmitted to the destination is called a message signal. So here this message signal contain the information of a user. Next is carrier signal. It is a high frequency signal which has characteristics like amplitude, frequency and phase, but it doesn't contain any information. Next is modulated signal. It is a mixture of message signal and the carrier signal. So here the devices are used for the modulation and demodulation process is known as modulator and demodulator. So modulator is a device that perform modulation and demodulator is a device that perform the demodulation. There is also one device that is known as modem which can perform both the operation modulation and the demodulation. Next, this diagram is showing how modulator work. Here what happen, a baseband signal, that is the message signal of a low frequency, is sent to the modulator. As well, the RF oscillators generate a carrier signal of high frequency. At modulator, these two signals are combined, that is low frequency signal and high frequency signals are combined together to generate a high frequency signal that is known as modulated signal. So this generated high frequency signals can travel to a longer distance. So this is work of a modulator that combines the baseband signal and the carrier signal. So at the demodulator process, what happens? The modulated signal that is received at the demodulator is passed to the demodulator. Here demodulator work as the separator. It will separate the baseband signal and the carrier signal. So this baseband signal is separated, that contain the information of the user, and this carrier signal is separated, that is the high frequency signal. Now this message can be used by the destination at the destination device. The next one is the what is the need of the modulation and transmission. So the modulation is used in the wireless communication so that the signal can travel to a longer distance. It is this modulation also reduce the noise and it also reduce the antenna height. So this is a cost effective method to deploy any communication process. Next is it avoid external signal interference and it is used in wide range of communication process. The next is the type of modulation. The first one we are going to discuss about the analog modulation. So here the analog modulation is used as a message signal which modulates the analog carrier signal. So here the analog message signal is used which can modulate a analog carrier signal. So the type of analog modulation are amplitude modulation, frequency modulation and the phase modulation. So in analog modulation, the characteristics such as amplitude, frequency or phase of the carrier signal is varied in accordance with the amplitude of the message signal. So this diagram is showing how this modulating signal or the message signal and this one is the carrier signal. So these signals are modulated together to form this modulated signal. So here you can see that the carrier wave amplitude is varying in accordance with this modulating signal, that is the message signal. Next let's discuss about the analog modulation, that is amplitude modulation. So here the amplitude of the carrier signal is varied in accordance with the amplitude of the message signal. So the frequency and the phase of the carrier signal remain the same. Here the advantage of this amplitude modulation is that there is a simple design of a circuit, and it is of low cost. But here the disadvantage of the amplitude modulation is that this is a less noise proof modulation process. The example of this amplitude modulation is that it is used in an amplitude modulation radio broadcast. This is the diagram that is showing this is a carrier wave of high frequency. This is the modulating wave. So here you can see that in modulated signal, the carrier signal is modulated, the amplitude is modulated as accordance with this modulating signal or the message signal. Next is the frequency modulation. Here the frequency of the carrier signal is varied in accordance with the amplitude of the message signal. The amplitude and the phase of the carrier signal remain constant. The advantage of this process is that there is a low channel noise, and in disadvantage is that this is a complicated process, and the example of this is FM radio broadcast. So here in this diagram you can see this is a carrier wave, this one is the message signal, and here the carrier wave is modulated as accordance with this modulating signal. So there the frequency, when the message signal is high, there is a high frequency modulated signal. When there is a low signal, then is low frequency signal. Again this is high message signal, there is a high frequency signal, then there is a low frequency signal. So it is modulating the frequency as according with the modulating signal. The next one is the phase modulation. Here the phase of the carrier signal is varied in accordance with the amplitude of the message signal. So the amplitude and the frequencies of the carrier signals remain constant here. The advantage of this process is that there is no channel noise, and the advantage of this is that this is a more complicated circuit than the frequency modulation, and this is used in a satellite communication. So here this is a carrier signal of high frequency, message signal, this one is a message signal low frequency, and here the modulated signal. So here you can see that the phase of the carrier signal is changed in accordance with the message signal. So as there is a high signal, the phase is changed, and when it goes to the low signal, then the phase of the signal is again changed. Again the signal is changing its message signal is changing its phase. Now here the modulated signal again changes its phase. So here the modulation is occur at the phase, and here the phase of the carrier signal is changed in accordance with the message signal. Next is the type of modulation, that is digital modulation. Here the digital modulation is as similar to the analog modulation, but here the baseband signal is of the discrete amplitude level form, that is there is a representation of high level and low level, high level with 1 value and low level with the 0 value. So it is representing the binary signal 1 and 0. So the digital modulation technique is employed for the efficient communication, and the main advantage of the digital modulation over the analog modulation is that it includes high noise immunity, it has high bandwidth, and the high permissible power. So the type of digital modulation are amplitude shift keying, frequency shift keying, and phase shift keying. So here this is depicting the digital modulation. What happened, this is a digital signal which goes to the digital modulation, and this one is a carrier signal of high frequency. They are combined together at this modulator, and this signal will come out as the process. So let's discuss about the first, that is amplitude shift keying. Here it is a type of amplitude modulation. It represents the binary data in the form of variation in the amplitude of the signal. So the ASK modulated signal shows the low input will show the 0 signal value, and high input will show the some carrier output. So this is also known as on-off keying, and the advantage is that this is a simple circuit, and disadvantage is that it is more susceptible to the noise interference. So this amplitude ASK is used in our infrared remote control, and also used in the fiber optical transmitter and receiver. So here you can see that this is the carrier signal of high frequency, this is the digital signal of low frequency. Now you can see that at the modulated signal, when the message signal is high, there is a frequency representation of a carrier wave with high frequency. When there is a low bit, then what happens here in modulated signal, there is no signal representation, that is carrier signal is representing no signal here. So this is the form of ASK. Next we are going to discuss about the FSK. So this is a frequency modulation, and the frequency of the carrier signals varies in accordance to the change in the digital signal. So the FSK modulated signal shows that the low input will show the low frequency signal and high input will show the high frequency signal. Here the binary 1 and 0 are also called as mark and space frequencies. So here this is used in the modem for the telemetry systems. This is a carrier signal and this one is a message signal with high and low input. So when there is a high input, there is a low frequency signal. When there is a high output, then there is a high frequency signal. When there is a high input, then there is a low frequency signal, and when there is a low input message input, then there is a high modulated signal, high frequency modulated signal. So this is the process of FSK. Next is the phase shift keying. Here it is a key type of phase modulation, and here the phase of the carrier signal is changed by varying the sine and cosine input of at a particular time. It's further of two type, that is BPSK and QPSK. BPSK is the binary phase shift keying and QPSK is the quadrature phase shift keying. So here in BPSK, this is also known as two-phase PSK or the phase reversal keying. And this technique, the sine wave carrier take two-phase reversal such as at the 0 degree and at 180 degree. So here the BPSK is basically a double sideband separation carrier modulation scheme that is used for message for representing the digital information. Next is quadrature phase shift keying. Here this is a phase shift keying technique in which the sine wave carrier takes four phase reversals such as 0 degree, 90 degree, 180 degree and 270 degree. So this kind of technique are further extended in PSK, can be done by 8 or 16 value also depending upon the requirement. So this is the type of PSK, that is BPSK and QPSK. Next we are going to discuss about the how the PSK works. So here this is a carrier signal and this one is a modulating signal. Carrier signal is of high frequency and modulating signal, that is message signal, is of a low frequency. So here what happened, when there is a high signal at the message part, then there is a this phase, and when it change adds to the low signal, then the phase again change, then it's changed to the high signal, then here the phase change occur. So in this way the PSK work. So this is used in ADSL broadband modem, it is used in satellite communication and in the mobile phones. Next we are going to discuss about the QAM, that is quadrature amplitude modulation. So there it is formed by combining amplitude modulation and phase shift keying modulation technique. It is a method of combining two amplitude modulated signals into a single channel which enhance the bandwidth. So QAM is used with pulse amplitude modulation in digital system and it is especially used in the wireless application. So in this the two carriers are shifted in phase by 90 degree and they are modulated, and the resultant output consists of both amplitude and phase variation. So the waveform occur according to the constellation diagrams, and the most common form of QAM are 16 QAM, 64 QAM and 256 QAM. So this is all about modulation. Thank you.